All right, we're going to look at a derivative as a function here. So what this problem's asking us to do is find the derivative of this function at x equals 0. Derivative is the rate of change when we're looking at it. So we want to find what's the rate of change at 0. What you notice about this graph is it is a piecewise function here. This function f of x. It's the graph of negative x when x is less than 0, and it's the graph of x squared when x is greater than 0. And they have the same value at 0, so one of these would have equals to it. Doesn't really matter here. So what we're going to do is find what is the derivative of each side here. Let's start with the right side. So we want to find what is the rate of change here at 0. So we're going to use our limit definition here to do that. What's the limit as h approaches 0 here of this function at 0 plus a little bit minus our derivative at 0 all over h here. So what's this going to come out to be? So first let's plug in what these would be. F of 0 would be, in this case, our function is x squared, so f of 0 would be 0 squared or 0. So this is just going to be minus 0. What's f of 0 plus h? So f at 0 plus h would be 0 plus h squared, which is just going to turn into 0 plus h is just h, so it's just turned into h squared. Simplifying that now, this would just be the limit as h approaches 0 of h squared over h, because we're minusing 0, it's nothing. We can cancel out one of those h's. Now it's just limit as h approaches 0 of just h. And now we can plug 0 in. That's just going to equal 0. So that means on our graph here that as this is curving down here, the rate of change right at 0, the slope is 0 right there. It does become 0 right at 0, so we get a rate of change of 0. All right, let's look at the other side. The other side's a lot easier. We don't even need to do that limit definition, because remember, it's the rate of change, and this graph has a constant rate of change, which is our slope. So what is the slope of this line everywhere? Well, this is just a y equals mx plus b line. Our derivative or rate of change should be our slope everywhere because it's constant, and this graph being having a negative there means our slope is -1 x plus 0, or just y equals -x. And so our rate of change for this one at 0 is going to be a rate of change of -1. And so what does that mean then? So if we have a rate of change on this side of -1 and a rate of change at 0 on this side of 0, is this graph differentiable? And differentiable again means is this graph have a derivative? That's what differentiable means, at x equals 0. Well, in this case, we would say a big no on this one. And the reason is the derivative is not the same on both sides. So we don't have a derivative at this point. Derivative is not the same. So the derivative has to be the same on both sides in order to have a derivative. So this graph at 0 does not have a derivative, or is not differentiable. It's differentiable everywhere else, but not at that particular location.